Hello, pre-cal type people. Hope you're all having an amazing day so far. Today, there is no easy way to say this. This is going to be about power functions. Power functions are just x to a power, right? We're going to go through and we're going to talk about what each type of power function gives us, all that kind of jazz. It's going to be fun and amazing. Can't wait. So n represents the degree of the function. And n has to be a whole number. That's what an integer means. Bigger than or equal to 0. So, like if this was f of x equals x to the first power, or just x, right? In other words, if n is 1, then we would call that linear. It'd be a line, right? If this was just x, it would be a line. What if it was squared? Well, then it'd be quadratic, right? It'd be a parabola, which would make it a quadratic function. So think about this here. Number 1 says to graph the following functions on the window -5 to 5. I've already got them typed in here. It's x squared, x to the 4th, x to the 6th, x to the 12th, and we're going to graph it on the window -5 to 5. And look at what this does on this graph. Okay, so here's x squared, x to the 4th, x to the 6th, there, x to the 12th, there he is. So notice it kind of gets squished in, right? And if you just graph one of these, let me go back and I'm going to turn these off. Actually, I'll leave that one on and we'll just compare it to x to the 12th. We'll turn these other two off. Here's x squared, here's x to the 12th. Look at how straight on this axis it is. I mean, that's pretty intense. If you zoom in, -2 to 2, it becomes a little bit more dramatic. All right, there's x squared, and here's x to the 12th. All right. So a couple of points on that. If you notice, they all cross at the same point, and that's when x is 1 and -1. That's because -1 squared is 1, -1 to the 4th is 1, -1 to the 6th is 1, -1 to the 12th is 1. So if you plug in a -1 in here, they all have the points -1, 1, 0, 0, and 1, 1 in common. They all share those 3 points right here. Let me turn these others on. They all have these points, -1, 1, 0, 0, and 1, 1, all in common. Alright, so and then there's the area near the origin too, so all that's taken care of. So let's talk about the two different types of power functions. You've got what if x is to an even power, like x to the n where it's an even number, then we would call this function even. And here's what they look like, right? Here's like x, here's an even power, an even power, an even power. It's even because it's reflected across the y-axis. And for x is less than -1, or x is greater than -1, if you notice, outside of -1 and 1, that it gets steeper as it increases. Like this would be x squared, this would be x to the 4th, x to the 6th, x to the 12th. So outside of -1 and 1, the graph is going to get bigger it's going to get steeper as it increases. The graph gets steeper as n increases. And here's what it's talking about. -5 to 5, -5 to 5. Here's x squared, little steeper than that, x to the 4th, little steeper than that, x to the 6th, little steeper than that, x to the 12th. Slightly steeper, right? It's getting steeper outside of 1. And then inside of 1, zoom in. Alright, so it's more shallow. You see that right there? That's x to the 4th. There's x to the 6th. Here's x to the 12th. So it gets flatter. It's like the bigger the number, it looks more like you're kind of taking a, like if this was a big foam finger and you're pushing it against a wall, right? The harder you push, the higher the exponent, the flatter the tip is going to get. So here the graph gets flatter. In behavior, as x goes to negative infinity and as x goes to infinity, so if you keep going left and right forever, your y values are going to go to positive infinity. Now this one does have a lot of information on it, so I'm going to try and go as quickly as I can. I mean, you can always watch it again if you miss it. Alright, now these guys. I'm going to graph x to the third, x to the fifth, x to the seventh, and x to the 11th. My window should go from negative 30 to 30, or the window negative 5 to 5, excuse me, for x, and negative 30 to 30 for y. This is to show you, just to make it a little bit more dramatic. There's x cubed to the 5th, to the 7th, to the 11th. Alright? So again, it gets steeper. But they all have the same point in common. Let me go back to Zoom 6 here. Look at the points that they share. Good. Matter of fact, let me zoom in even more than that. You can really see this thing. I broke it. I broke calculus. You get the idea. Anyway, there's a graph of it on here. They have certain points in common. If you plug in a negative 1 into x cubed, you're going to get a negative 1. If you plug in a 0, you're going to get a 0. And if you plug in a positive 1, you'll get a positive 1. Right? Because negative 1 times negative 1 times negative 1, 3 times, 3 negatives, that makes it negative. Okay, so for odd functions, here we call these functions odd. And again, it gets steeper outside of 1 and negative 1. The graph gets steeper. And the graph gets flatter on the inside, between negative 1 and 1. That's right at the origin. It's going to get more squished, right? So going to negative infinity, this way, your y's go to negative infinity. Going to positive infinity, your y's go to positive infinity. All right? So let's talk about a couple of these here. We're going to talk about the cubic and quartic function. This will really be about as high as we go for now anyway, just to start us off. The parent cubic function, let's plug in a negative 2, negative 1, 0, 1, and 2. So what is 2 cubed? 2 times 2 times 2 is 8. 1 times 1 times 1 is 1. 0 times 0 times 0 is 0. Negative 1 times negative 1 times negative 1 is negative 1. And negative 2 cubed is negative 8. So coming over here and graphing these, negative 2, negative 8, here, 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 and 2, 8. Pause the video if you need to, get those points down. And these are not straight lines, these are curves, right? Curves. Like that. That's called the parent function. Your domain, your x's are all real numbers, your range is all real numbers. Remember that this is an odd function. It's also one-to-one. That means it passes the horizontal line test. Drop a horizontal line, it only hits once everywhere. It's also odd means that it has an origin symmetry. Right? It's always increasing and it goes through the origin. So you can imagine what we're going to do with this eventually is take this and start manipulating it. X cubed plus 3, negative parentheses, x plus 3 cubed, shifting it up, down, left, right. So just like the parabola, how we counted off 1, 1, 1, 3, 5, 1, 1, 3, 1, 5, 1, going up 1 over 1, up 3 over 1, up 5 over 1. Same thing here, up 1 over 1, up 7 over 1. just because it's cubed. All right, so you kind of need to remember that. This one down here, quartics, we have -2, plug that in there, you get -2 times -2 times -2 times -2 is a positive 16. Plug in a -1, you get 1. Plug in a 0, you get 0. Plug in a 1, you get 1. Plug in a 2, you get 16. So here's what this one looks like. This, and this. But this is going to be much flatter than a parabola because it's going to hit before, because 16 is off my graph. Before I hit 2, I'm off my chart. Like this. So before I get to positive and -2, I know it kind of looks like my graph is wavy a little bit, but just remember it is a curve. There we go, much better. Domain, your x is all real numbers. Your range is 0 to infinity. A lot like your parabola. And again, we're just going to do stuff to it. It's an even function. It goes through the origin 0, 0. Just good stuff. And then we're just going to modify it. We're going to do stuff to it. So flipping over to the last page here. All right. Going to the last page, we have x minus 3 cubed minus 2. Now, this the vertical shift, horizontal shifts, they all stay the same, okay? So for number 3, this still says right 3. This still says down 2. So I'm going to go from 0, 0, go right 3 and down 2. Notice I'm not changing a horizontal stretch or shrink. So it's up 1 over 1, up 7 over 1. And it's down 1, left 1, down 7, left 1. There you go. Domain, range. Sorry, someone's in the hallway and shouldn't be. Ha! All right. So again, it's just right 3, down 2. So the same rules still apply. All I'm doing is a different shape. That's all it is. It's the same rules. It's just a different shape. So number 4 here, same rules, different shape, right? Same rules, different shape. Now, if all else fails, your go-to on this is to just make an XY chart. Now, you can go ahead and tell me that this is moved up 4 and that it's a y-axis reflection, or excuse me, x-axis reflection, right? It's going to be negative. And that it's a vertical shrink of a half, right? So it's going to be your y values divided by 2. Now think about this. If all else fails, pick points and plug them in. Plug in a 0. 0 to the 4th is 0 times a half is 0. Negative 0 is just 0 plus 4. Well, there's your up 4. Again, if you're just absolutely lost, plug in points. Plug in a 1 right here. This is 1 to the 4th, which is 1, times a negative a half. Negative 1/2 plus 4, 3.5. If you get lost, just plug in points. Plug in a 2. 2 to the 4th is 16, times negative a half is negative 8 plus 4. Negative 4, 2, negative 4. If you get lost, plug in points. And I'm going to say that over and over and over and over and over again. If you get lost, plug in points. Especially on these bigger ones. Negative 1. Plug in, well, since this is even, I can actually just copy these points over. There's my graph. and there's no patterns to remember. I mean, you can do this with quadratics, you can do it with everything. It's a little easier to memorize the pattern with quadratics, but you can do points with anything. There's no reason to ever get a graph wrong. There is no reason to get a graph wrong. Plug in points. Number 5. Now this one takes a little bit more practice. This is obviously a cubic, right? So I'm going to need an x cubed. It's obviously left 3. So I'm going to need a cubic. It's going to be x to the 3rd power. It's going left 3, and it's also negative. It's going to be negative because it's going down on the right. So I'm going to say f of x is negative. How do you show x moving left 3? X plus 3. And then it's a cubic function, cubed. I'm not moving up or down. I'm not stretching or shrinking because I can see here it's down 1 over 1, down or over 1, down 7. I can see that right here. I don't need to stretch or shrink. I found this first point, I'm done. Down 1 over 1, perfect. It's not stretching. Number 6, it looks like a parabola, but this end is way too flat. It's obviously, it's going to be a quartic, right? Which means I need x to the 4th. Where's it going? It's going down 5. Show me something move down 5, right? It's x to the 4th. Now, am I stretching or am I shrinking? Well, they give me a point right here. This was up 1 over 1. Now it's up 2 over 1. So I'm stretching. 2x to the 4th minus 5. Done. If you want to go back and check it, plug in a 1 right here. And I should get negative 3. Plug in 1, you should get negative 3. 1 to the 4th is 1, times 2 is 1, minus 5 is negative 3. There should be no point, no reason you should ever have to get a graph incorrect. Plug in points. Number 5, let's check this point. This looks like a point down here. If I plug in a negative 1, I should get a negative 8. What's negative 1 plus 3? 2. 2 cubed, 8, with a negative in front of it. Negative 8. Order of operations is pretty important here. Plug in a 0, or plug in a negative 3. Negative 3 plus 3 is 0, all 0. Plug in negative 4. Negative 4 plus 3. Negative 1 cubed, negative 1, times negative, positive 1. There should be no point to getting a graph wrong ever in the history of never. All right? Have a fun weekend.